Hello, this video is to go over what we're going to do this week, and most of it is with backtracking again. First thing I want to review is the discriminant. Remember, in the quadratic formula, that piece is the inside of the radical, the b squared minus 4ac. So when you solve the quadratic equation for the discriminant, if the inside is positive, you're going to have two solutions. If the inside is negative, you're going to have no solutions. And if the inside is zero, you're going to have one solution. So for example, if I do this one, b squared in this case, 5 squared is 25, minus 4 times my a, which is 3, times my c, which is negative 2. Well, negative 4 times 3 is negative 12 times negative 2 is 24. So 25 plus 24. So the inside is 49. So I know I'm going to have two solutions, which means I'm going to have two x-intercepts. If I do the same thing here, if I do b is 1, so negative 1 squared minus 4 times a times c. And when I do the math, this would be 1. I have three negatives. So when I multiply these, I'm going to get negative 120. And 1 minus 120 is negative 119. And that's going to be a number where I cannot solve a square root of a negative number. You can do that when you'll call it imaginary numbers. We'll learn that more in Algebra 2. But for right now, it's not possible for real numbers. So that means I'm not going to have any x-intercepts. If I go ahead and do this last one real quick, b squared, so 6 squared is 36, minus 4 times a times c. And this would be 36 minus 36, which is 0. So then I only have one solution. So one of the things that we're going to talk about this week is how many solutions are possible. So anytime you do a quadratic equation, it's either going to have 0 solutions, 1 solution, or 2 solutions. Another family that's like that we've talked about in the past is absolute value. And I'm going to go through an equation that you have to backtrack and solve for that deals with absolute value. And there's some special rules when it comes to backtracking for absolute value. So as we look at this equation, remember the absolute value is like a grouping symbol. So I want to get rid of all the things outside of the grouping symbol first. So I'm going to get rid of adding, subtracting before multiplying and dividing. So the first thing I would do in this particular question is add 7 to both sides. So now I have 2 times the absolute value of x plus 9 equals 35. Now I want to get rid of this 2. Since I'm multiplying by 2, I'm going to divide both sides by 2. So now I have x plus 9 equals 17.5. Now this is still the absolute value. Now what's special about absolute value is once you get to this stage, there's two possible solutions for this. So what you want to do is you want to make your absolute value equal to 17.5 and then make it equal to negative 17.5. And again, you don't do that until you get just to the absolute value sign by itself. So I have one last step. I'm going to subtract 9. So I have x is equal to 8.5 is one solution. And if I subtract 9 on both sides on this one, I'm going to have x equals negative 26.5. So again, here's a situation where I'm backtracking for absolute value, and I'm going to have two solutions. There are some other things I want to review as far as different levels of backtracking that you'll also see. So if I have this following one, 5 times x plus 13 squared equals 500. Again, I'm going to solve this by what we talked about last week, undoing, which is another way of saying backtracking. So I'm going to get rid of the multiplying before the power. So I'm going to divide both sides by 5. And I'd have x plus 13 squared equals 100. The opposite of squaring is to square root. And remember, when you backtrack and square root, your answer is both plus and minus. And the square root of 100 is 10. So I have one more step. I'm going to subtract 13 on both sides. So now I have negative 13 plus and minus 10. Well, negative 13 plus 10 is negative 3. and negative 13 minus 10 is negative 23. So these would be my two solutions to this backtracking question. Um, Sometimes you'll have symbols that are the radical sign. So if I just backtrack this one real quickly, again, I want to get rid of the 3 on the outside, so the opposite of multiplying by 3 is to divide by 3. So now I have x minus 3 square rooted equals 4. To get rid of a square root, the opposite is to square. So if I square 4, I would be at 16. So then I have one more step. I have to add 3 to both sides. So this would be x equals 19. So again, just different forms of backtracking. The last one I want to go over right now is one that seemed to give some of you some questions when I looked over your work from last week. And that's when we have that equation where we have to deal with two bases and solve for x that are not the same. So remember, to solve these types of questions, you need to make the base so they're both the same number. If I look at 1/4 and 8, the common base that comes to mind is 2. 2 to the negative second is 1/4. So if I times that by the power that's already there, and 2 to the third power is 8. So now I'm going to go ahead and distribute. So negative 2 times 3x is negative 6x, and negative 2 times 1 is negative 2. 3 times x is 3x, and 3 times negative 2 is negative 6. Now that I'm done distributing that, because they have the same base, I just make them equal to each other and I backtrack. So now I'm going to add 6x to both sides. So now I have negative 2 equals 9x minus 6. I'm still going to get the x by itself, so I'm going to move the 6 over. So now I have 9x equals 4. My last step is to divide by 9, and I would get x equals 4/9. So if I put 4/9 in for x into both these, I would get the same answer